Welcome back. We are in Khan Academy on Algebra 1. We're in the unit Quadratics Multiplying and Factoring, and we're to the skill Multiply Perfect Square Binomials. In the last video we did Multiply Difference of Squares. This looks really similar, right? We've got one term times itself this time. Before we had something plus another times the same first term minus the other. So the only distinction between this and the last one as far as the factored form goes is that both of the signs are going to be the same. In this case, they're both positive. All right? So let's look at what happens when we expand this, use the distributive property, and we get x times x is x squared, plus x times 2 is 2x, plus 2 times x is another 2x, plus 2 times 2 is 4. Combine the like terms and you get x squared plus 4x plus 4. That's our solution. Now, just like in the difference of squares video, this is so common that it got a special name, and its name also makes sense. If you think back to when we were doing rectangle areas, that will help us figure out how this is working. So let's say that each of these factors is the dimension of a rectangle. In that case, the dimensions are the same, and thus our rectangle is a square. So we could make a picture of it. It would look like this. X plus 2 and x plus 2. And when we multiply the length times the width, we get our area in here, which was x squared plus 4x plus 4. If you break that apart, like they did on the videos before, you would get something that looks like, let's say, it looks like this. X plus 2 and x plus 2. So your x squared term is x times x here. You have 2 times x here and 2 times x here and 2 times 2 here. So x squared plus 4x's plus 4 is our total area. Now, it's called perfect square binomial because we can model it with a square, an area. And so this formula is going to hold true. We're going to generalize it in a moment, but let's first enter our answer here. So x squared plus 4x plus 4. And let's look at what they give us for our next one. This one, x minus 5 squared, they wrote it a little differently because the dimensions of our square are the same, the height and the width are the same. We can write the factors with an exponent. So first let's rewrite that without the exponent. So x minus 5 times x minus 5. And that's x squared minus 5x minus another 5x minus 5 times minus 5, or negative 5 times negative 5 is positive 25. And we combine these terms and we get x squared minus 10x plus 25, and that's our solution. So we'll write it in here, x squared minus 10x plus 25. Okay, so that confirms that that's true. Now, let's generalize this, all right? So we're going to, instead of having an x and a particular number, we're going to just go back to a's and b's, so it could be anything. So we have a plus b squared we can rewrite that a plus b times a plus b. Now, we can expand this, so a times a equals a squared. That's a times a. A times b is ab. B times a is also a times b because of the commutative property of multiplication. And b times b is b squared. Okay, so when we look at this, we can combine like terms. We've got ab plus another ab, that's 1 and another, that's 2. So we can say a squared plus 2ab plus b squared. And that is equal to that. All right? Now, notice in this one, our middle term had a negative. Why was that? That's because the sign in here was negative. So if b is negative, we're going to have a times a negative number, which will be negative, and we'll have b, which is negative, times this positive. So we get a negative and a negative number, and that will change this sign. Now, we don't have to write that in general, because if a is positive and b is negative, that makes this term negative. Fine, fair enough. So let's write in general what we know now. We know that a plus b squared is a squared plus 2ab plus b squared. And we're going to use this general truth that's always true to solve the next few problems without having to do the middle steps. That's what math lets us do. It lets us make life simpler by generalizing and finding truths that we can apply. Okay, next question. So 2x minus 3, that's the same factor as 2x minus 3, which means we're squaring that factor, so it will end up expanding in that form. We take our first term and square it. 2x times 2x is 4x squared. Then we're going to add 2 times our first term times our second term. So 2 times 2x is 4x. So it'll look like this. 2 times 2x times our second term. Our second term is negative 3. Why is it negative? Because this sign is negative. We're adding some constant. In general, we're adding a constant. Well, in order to have it be subtraction, that means that constant had to be negative. Okay? So our middle term is 2 times 2 times negative 3. That's negative 6. Oops. Negative 6 times 2 is negative 12. So it's negative 12 times x. And then, last term is being squared. So negative 3 times negative 3, that's negative times negative, always positive, positive 9. Now you'll notice, because we're squaring the last term, it's always going to be positive. Positive times positive is positive. Negative times negative is positive. So when you expand a perfect square binomial, the first term will be positive because you're squaring, and the last term will be positive because you're squaring. The middle term will have whatever sign is in both of these factors because it's the same factor. Okay, so we can answer this one. We'll go to the next one. I would pause if I were you, try to solve this. 2x plus 3, that quantity squared. Assuming you've had a go at it, we're going to square the first term. 2x times 2x is 4x squared. We're going to multiply the first and second term. 3 times 2x is 6x. Multiply that by 2, and you get 12x. And then we're going to square this second term. 3 times 3 is 9. we're done.